Hi everyone, this is a video going through the Quadratics 2 notes and Unit 5 of the Nat 5 Maths course. So what we are looking at for the bulk of this unit or this topic is to solve quadratic equations. Okay, so you can see that's the top heading up the top there. We looked briefly at this when we did quadratic graphs back in Unit 3, maybe. I might stand to be corrected on that one. And it's basically when we have, when we had our calculations previously, we maybe had like x squared plus x minus 2 equals 0, and we would factorise into two brackets, and then we'd set each of those equal to 0 separately on its own. That's the first, essentially the first big thing we're going to do within this topic. So we may have, for the first couple of lessons, a bit of an advantage since we've already seen this before. Okay. Now, those two values of x, when we create them, are known as roots of the graph. Okay. Additionally, they are also where the graph cuts the x-axis. Okay. So, if we look through this little blurb here at the start of the notes, we have the top sentence there tells us that we're always going to get two solutions. Okay, so we've got two solutions for x. Sometimes these solutions are the same number, and we'll look at that case in a second and what that means for the graph. But we'll generally end up with two solutions. Okay. The very, very main thing, a crucially important thing, is that our function, our graph of x squared and so on, has to be equal to 0. If it is not equal to 0, then we must first rearrange so that we have all of our terms on one side and 0 on the other side of the equal sign. Okay. Now, the grey box there tells us that the solutions of the quadratic equation, so once we've got our two values of x, are known as the roots of the quadratic graph, and that is where the graph cuts the x-axis. So for this graph here, we can see we've got x squared minus 3x. We factorise first of all, and it's not done here, but we'll see how that happens. So we factorise first of all, and we get the two values x equals 0 or x equals 3. And on the graph, once this graph is plotted, that's where the graph actually scoops up and cuts the x-axis in those two positions. So that's essentially what we're finding, where the graph cuts the x-axis. We did this when we were drawing these graphs because we had to also mark on the x-axis point. So that's when we saw these a bit before in the notes. So most often we will need to factorise our terms on the left hand side to be able to then split up into two brackets and so on. But these first few examples just give us the two brackets already. Now, if we have two brackets, or as in the first example, two terms equal to 0, we know that either one of them has to be equal to 0. Okay, because the two brackets here are being multiplied together, and therefore one of them must equal 0 in order for the product to be 0. The only reason that you can times two things together to get 0 is if one of them is equal to 0. So for 1a, we know that either x equals 0, in this case, because one of our terms is x, or that x plus 1 equals 0. And I just write out my solutions like that with the two lines underneath just to make sure that I've got both of them written down. So one answer to A is x equals 0, but the other answer we have to try and solve this equation. So x plus 1 equals 0, take away 1 from both sides, so x equals -1 is the other solution. Just make sure that you do get it down to x equals something rather than x plus 1 equals 0. B then, we take our two brackets separately, so it's x minus 5 equals 0. So this means that x has to be 5. or x plus 3 equals 0, which means x equals minus 3. So we've got x equals 5 or x equals minus 3. Now that tells us if we put either of those two numbers back into the equation, we will get 0 out as the answer. Lastly then, two separate brackets here, so 2x plus 5 equals 0. So then solving this equation, 2x equals 5, x equals 2.5, and then the next one, 3 minus x equals 0, so that will be x equals 3. Think of that one as being 3 take away what gives you 0, so it's 3 take away 3. Okay. As I said at the start of this, the more often than not we will have to actually factorise the side, the left-hand side into two brackets before we then go on and split up the two brackets there. So that's what we're going to do next. Now, that's what this black grey box up here tells you to do. So your steps here are to check that the right hand is equal to 0. Now, in most of these, the right-hand side will be equal to 0. Factorise the left-hand side if it's not already in brackets, and then solve for each bracket. So, to factorise, we have got to do our various different methods. So we could take out a common factor, we could use difference of two squares, or we could use our trinomial factorising. The good thing about coming back to this in Unit 5 is we actually take the stuff we did in Unit 1 and just transfer it all the way through to Unit 5. So it is quite a good thing to be able to do here. So, for example 2a, we can take out a common factor of x, which leaves us with x plus 11 inside the bracket, and that equals 0. Applying what we did then up above, either x has to be equal to 0 or x plus 11 has to be equal to 0, and therefore x is 0 or negative 11. Okay, we can apply that process throughout as well. So the next thing we can do here in B is to take out a common factor as well. Common between those two terms on the left hand side is 3 and also x. So 1 is left when we divide the first term by 3x, and we have 2x left over from the second term. All of that comes together to equal 0, and we take our two terms separately to find out what x is equal to. For the first one, 3x equals 0, so x equals 0. Don't change that to 3. 0 divided by 3 is still 0. 1 take away 2x equals 0. So that would tell me that 2x equals 1 and x equals a half. Now you can leave these x values as fractions or decimals. I did decimals up above, fractions here. It doesn't matter. You generally don't have to use them again anyway, and if you do, you might end up with whole numbers. Okay. If you do have to use them again, I would change them to decimals rather than fractions, but we can discuss that when we come to it. So on to questions C and D. Another way that we can factorise our terms, so x squared minus 9, we can use difference of two squares. This is where we end up with two brackets. We have the same thing in both brackets, just one with a plus and one with a minus. So in this case, we have x plus 3 and x minus 3, and all of that equals 0. The x's coming from the square root of x squared, and the 3's coming from the square root of 9. Splitting those two up, either x plus 3 equals 0, which means x is negative 3, or x minus 3 equals 0, so x is positive 3. That's our two possible values of x. Question D, in this case, we can first take out a common factor. So we have to be wary of everything that we can do to factorise the left-hand side. First thing we can do is take out a common factor of 2, but then inside the bracket x squared minus 36, we can also factorise that into 2 separate brackets. Once we've done that, it'll all be equal to 0. Now, in those brackets, it's the difference of 2 squares, so we end up with x minus 6 and x plus 6. Again, the x's coming from the x squared being square rooted, and the 6's coming from the 36 being square rooted. Now, since we have 3 terms here, we know one of them has to be equal to 0. If I was to take all 3 of them, then the first thing I would say is 2 equals 0. But that's not possible. 2 is 2, it's not 0. So if we have a number out the front here, like we do with the 2, we don't need to include that in our next step. So we just leave that 2 out. So the first bracket, x minus 6 equals 0. The second bracket, x plus 6 equals 0. So x equals 6 or x equals negative 6. Okay. Since those two numbers are the same, just one positive and one negative, that's what happens within our answers as well. Now, the next set of questions here. So first of all, the first one is the difference of 2 squares again. Since we have 64, which is a square number, and x squared, which is a squared term, and a minus in the middle, it's still a difference of 2 squares. In this case, we end up with 8 minus x and 8 plus x. The reason the 8 has to come first is because the 64 comes first at the beginning. Splitting those two brackets up, 8 minus x equals 0, so x equals 8. 8 take away 8 would give you 0, which is how you can work that one out. 8 plus x equals 0, take away 8 from both sides, so x equals negative 8 in this case. Lastly, we can also factorise using our trinomial method. Now this is one that takes up the most amount of time when we do this, but it's, as I said, very good to be able to practice this all the way back from Unit 1 and then apply it into these questions as well. So when we do factorising using trinomials, we first of all list numbers that make our a, b and c within our trinomials. Now this process is going to become very, very useful to us in the next few lessons. Okay, so a is going to be in front of the x squared, b is always in front of the x, and c is the number on its own. There's no number in front of the x squared, so that's 1 in this case, b is 6, and c is 5. We then worked out what a times c was, which was 5. So now I am looking for two numbers that multiply to give me 5. We've got to multiply to give me 5 and add to give me 6. So think of the two numbers that multiply to give you 5. The only two there is 1 and 5, and those do add to give you 6. So we know it has to be 1 and 5. Okay. Therefore, we take the numbers 1 and 5 and we replace the 6x by both of those numbers with x's in front of them. So x squared plus x plus 5x plus 5. This is going right the way back to Unit 1, so don't worry if you've forgotten about it, we will have time to practice it today. So to complete this question, we have got to first factorise the first two terms, making that x bracket x plus 1. We split this in 2, we use the same symbol. Factorise the second two terms, take out a common factor of 5, making that 5 bracket x plus 1. Our two brackets then become x plus 1, which is the common bracket, and everything else that is left over, x plus 5. Set that equal to 0, and then we have our two brackets equal to 0, so we can find out the two values of x. X plus 1 equals 0, so x equals negative 1, or x plus 5 equals 0, so x equals negative 5. Those are our two values. Now we will continue doing this for examples G and H, and then I and J will do it a little bit differently as well. So G and H, we will do the same process. Get our numbers for A, B and C, and then find out what A times C is. A is 1, B is 3, C is negative 40. Got to work out, got to be careful of that. So A times C is negative 40. That gives us then, we need to find two numbers that multiply to give us negative 40. And when we add them together, we get 3. So in this case, think of your numbers that will multiply to get 40. We've got 10 and 4. They don't combine to get 3. We have got 5 and 8. There's a difference here of 3, so that might actually work. One of them has to be negative, one of them has to be positive to get the negative 40, but they have to add to give positive 3. So negative 5 and positive 8 are going to work for that question. Replace those back into replace plus 3x with. We get x squared minus 5x plus 8x minus 40. Factorise the first two terms. X is a common factor, so we end up with x minus 5, plus, and then 8 is a common factor, so we end up with x minus 5. We know we're on the right track if we have the same bracket there, as that is one of our brackets in the answer, and everything left over, which is x plus 8, and we set it equal to 0. So x minus 5 equals 0, therefore x equals 5, or x plus 8 equals 0, therefore x equals negative 8. And that will be our two answers for G. For H, we do the same thing. We just end up with a coefficient of x squared this time, which means our A has to be 3. But the process is still exactly the same. So A is 3, B is 11, C is negative 4. A times C is equal to negative 12. Now the two numbers that will multiply to give me negative 12, but will add to give me 11, in this case have to be negative 1 and 12. Don't forget the number in itself, or itself and 1, can multiply to give you the number. So 1 and 12 multiply to give you 12, which means you can use those two numbers as well. You need 1 to be negative, it has to be minus 1 because 12 take away 1 gives you the 11. So let's make that 3x squared plus 12x minus 1x, so minus x is fine, minus the 4. Common factor between the first two terms is 3x, leaving you x plus 4. Keep the minus there, and we end up with x plus 4 as well. Now we can put a 1 in this one. If we don't have to take anything out, any common factor out of the second bracket, then we just keep the symbol and put a 1 there in front of the bracket. Therefore the two brackets are x plus 4 and 3x minus 1. Set that equal to 0. So x plus 4 equals 0, x is minus 4, 3x plus 1, minus 1 equals 0. 3x equals 1, x equals 1 over 3. So our two values for x for this example are minus 4 and 1 over 3. Okay, so these questions are very, very similar. The only thing we have to do at the beginning is to rearrange to make sure that we have 0 on the right hand side. So for the first one, it's relatively straightforward. We just need to remove the 14 from the right hand side, move it over. We can take it away then and make that x squared plus 5x minus 14 equals 0. We now have all the conditions to do A, B and C, A times C and so on, and continue down. So A, B and C are 1, 5 and minus 14. A times C is minus 14. Numbers that multiply to give you 14, probably going to be 2 and 7. I need one of them to be negative. It has to be negative 2, since negative 2 plus 7 gives me the 5 in the middle for the b. So x squared, replace those two in, so make it minus 2x plus 7x minus 14. Take out a common factor of x from the first two, so that's x minus 2. Take out a common factor of 7 from the second two, and you get the x minus 2 coming out there as well, which is what we want. And finally, we will get x minus 2 and x plus 7. Set that equal to 0. X minus 2 equals 0. X equals 2. X plus 7 equals 0. X equals negative 7. And we end up with those two values for our final answer. Question J is just slightly more complicated than I. The first thing I'm going to do is to try and make J look like question I, kind of. In which case I'm going to have to multiply out this bracket. So there's two brackets here. We can do x times x times 3, minus 2 times x, and minus 2 times 3. Again, taking in something from Unit 1. When we multiply out those brackets, we're going to end up with x squared plus x minus 6, and that is going to equal to 6. I've not touched the 6 on the right hand side just yet. Okay, so it's plus 3x minus 2x, which is why I've got just plus 1x in the middle. Take away the 6 then, we end up with x squared plus x minus 12 equals 0. I'll get rid of that minus 6 on the end because we don't need it anymore. Now we have all of the conditions. We have it equal to 0, so we can now do our a, b's and c's. A times c, and then calculate our two brackets. 1, 1 and minus 12. Two numbers that are going to times to give us minus 12 are minus 3 and 4. We need one of them to be negative. It has to be minus 3, since minus 3 add 4 gives us the 1 that we need to create for b. Okay, so that a times c is minus 12 there. Now we replace the minus 3 and the 4 back into the original question. So x squared minus 3x plus 4x minus 12. Factorise the first two terms, so x bracket x minus 3 plus 4 bracket x minus 3 for the second two terms, and our two brackets are x minus 3 and x plus 4. Set them equal to 0. Use your two brackets then separately, so x minus 3 equals 0, x equals 3, x plus 4 equals 0, x equals negative 4. Okay, so it might take us a little bit of time to get used to the factorising methods again, but once we get there, it's just a little bit extra that we have to do on the end for these questions. We are going to spend the first double period on Wednesday, period 1 and 2, doing these questions. And I'll do a call at the start as well, so we'll be able to go through them and ask questions. Okay. I will give you a list of questions on the Teams page, and I will give you the worksheet as well, which I'll take in from the Unit 5 booklet, but I'll just give you it as a worksheet with the particular questions and pages to do. Okay. I'm going to stop this video here and give you the rest of the notes on another video, just to kind of split things up a little bit more with this topic. Okay.